and welcome to this video. We're going to look today at the idea of forces and how a force can impact the motion of an object. So if you're ready to go, you should have a notebook. If you're in my lessons, you should be aware of the types of notes you need to take down, and we'll get started. Now hopefully by now from your prior learning, you should be aware of what a force kind of is. At Key Stage 3, we define a force as a push or a pull. Now at Key Stage 4, GCSE Sciences, we have to be a bit more specific than that, and even more so when we get into our A-levels and IB. For now, we'll just take the idea that this ball here, for example, is being pushed by a force. Now a force is a quantity that we measure in newtons. We could use a Newton meter to measure that force. Here in this case, you can see an arrow pointing to the right, and the size of that arrow is 3 newtons. So what we're doing here is we're pushing the ball with a force of 3 newtons. Now what you may not have considered previously is what the forces do to bodies. Well, forces for physics generally tend to cause acceleration. There are other things we can think about, and we'll talk about them in a second, but for now we'll just think about acceleration. Casting our minds back to the equation for acceleration, accelerations are linked to the change in speed. So if we had a ball which is stationary and we pushed it with a force, then it would accelerate to the right. So in this case, we've got acceleration to the right. You might have a stationary ball which suddenly gets faster due to the action of that force. Now these are very much the basics of forces that we need to know. We're going to try and make it a bit more complicated. If you're not sure at this stage, I'd recommend pausing the video and then making sure you've digested this before we move on. And where it gets a little bit more complicated is if we take more than one force. Now don't worry, for the 0654 course, it's actually relatively simple. Let's make this more complicated by adding in this force. Take a second to think, if we now had these forces acting on the ball, what would the effect of these forces be on that ball? And if you're ready to go on, feel free to keep watching the video. And hopefully you've had a bit of time to digest that one as well and have a little think. The reason that this is tricky is because forces are what we call vector quantities. Now vector quantities may be something new, particularly for the students in my lessons. We don't deal with many of these at GCSE, but it's something you need to be aware of. A vector quantity is something which has size and direction. So you can see that the two forces have different directions here because we've got one pushing to the right and one pushing to the left. We've got 3 newtons to the right and 5 newtons to the left. Vector quantities have to take into account the direction when we're adding them up. So if we wanted to find the total force here, you might be tempted to say, well, 5 plus 3 is 8. However, that's wrong, because they're acting in opposite directions. Actually, the 3 will cancel out some of that 5. The way we do this is using very, very simple maths to calculate something called the resultant force, and often we use the letter F to represent our resultant force. So let's see what the resultant force here would be. Well, we've got 5 take away 3, and the reason that we're doing 5 take 3 is because they're in opposite directions, leaving 2 newtons behind. The resultant force is a vector, so it needs a direction, and so therefore we'd say that the direction of this resultant force is to the left. In other words, 2 newtons to the left. And this is now different to the previous situation where we had only the 3 newtons we were accelerating to the right. We're now going to accelerate to the left due to the action of both of those forces. This is what's called calculating the resultant force. And in our course, really we have to just do this in one line, and it's usually quite simple kind of maths. However, when you get into more developed things in different directions, maybe right angles, the maths that you learn in GCSE is also very helpful there. Let's talk a little about the effect of these forces. There are a few things which could happen here due to the force. One thing that could happen due to the fact we have a non-zero resultant force, we might change the speed. It might get faster, it might get slower. We might change direction. We might have the ball initially traveling right and then beginning to travel left instead. Another thing it could do, which we've not discussed so far, is it could change the shape. This might be an elastic ball, and due to the squashing of those two forces, it might change the shape. And we see that later when we're studying springs, etc. So non-zero resultant forces will allow those three changes to happen. They might change the speed or the direction, acceleration, or it might change the shape. It doesn't change the mass of the object still stays the same mass. So, just to kind of wrap up, the forces that we've considered so far have been in the horizontal direction. However, often we look at the forces in the vertical direction. You've got three images here, A, B, and C. Okay, just take a second to have a look at the different forces in this case. When you're ready to see the resultant force on each one, click play and we'll talk them through. Okay, we look at A, okay, at time equal to 0. It's fairly simple. We only have one force, and so therefore we have 1 Newton acting down. The total resultant force is going to be, well, 1 Newton take away nothing, which is therefore 1 Newton downwards. We've got a total force of 1 Newton downwards. And we could ask, what will this then do to the ball? Well, if the force is downwards, it will accelerate downwards. This ball is going to get faster and faster. Now, at B, you notice here we've got a slightly different case. We've got 1 Newton acting down and 0.5 Newtons acting up. Well, we still subtract them. We now have 1 take away 0.5, which gives me 0.5 Newtons, and that's acting downwards. And the question is, what does that do to the motion? Well, we still have a total force acting down, and so therefore we're still going to accelerate downwards. What we'll learn in our lesson, however, is that the magnitude of that acceleration is going to change because our force has decreased. Last one, well, at time equal to 4 in C, we'll notice therefore we've got 1 Newton up and 1 Newton down. So therefore the resultant force here is 0. Now this is the bit that gets students a little bit confused, and it's really the reason that I make these videos, is to have a think, what does that mean about the motion? Well, if the force is 0, then what we're saying is 0 acceleration. In other words, it will not accelerate. What that then means, if we're staying still, then we're just going to remain staying still. We're just going to keep at that position that we're in. However, this is a falling ball. It was already moving. It's not accelerating, and so therefore it's just going to keep on falling at a constant speed. Okay, so 0 force doesn't mean 0 motion, it means 0 acceleration. And that's a key part that we need to establish as we learn through our physics course. However, especially for my students, we don't need to go into that just now. We'll learn that in our lesson. Please take a second to have a think about that. Try the multiple choice questions if you're doing this part of the Firefly task, and of course, come to the next lesson ready to go and with any questions that you might have. Thank you for watching.